Let's do the long way first. Last time we ended up learning concepts of fuzzy logic, membership functions, linguistic variables, and a degree of belongingness. One member can belong to multiple groups at the same time with varying degree of membership. Fuzzy set theory we are going to implement today in a simple expert system of calculating tip amount based on 3 fuzzy rules. All 3 rules are expressed in natural language, which is the very human way when you talk to an expert and try to understand their domain, get the knowledge from their expertise and try to make rules from them. They are most likely be in this format, natural language format. So here we have 3 simple rules. If the food is bad or the service is poor, then the tip will be low. If the service is acceptable, then the tip will be medium. If the food is great or the service is amazing, then the tip will be high. Now here we are not presenting these rules in terms of numbers, right? Because we started with the premise of not accepting numbers as specifically a good format to express uncertainty and fuzziness in the rules and situations that we humans come across on daily basis. The libraries we are going to use are based on scikit fuzzy library. You should actually go through the API from this source that I shared. I will explain the solution now. We have 2 input variables, food quality and service. Based on these 2 inputs, the fuzzy expert system should calculate an amount that you sensibly, following these 3 rules, pay to the service. And that is your output variable, tip amount. So let's import these packages first by installing scikit fuzzy package. You will pip install. You will need numpy and the scikit fuzzy package we will use as fuzz here. We are nicknaming it as fuzz. We will use matplotlib.pyplot to visualize how the system is working. Now, the universe of discourse term we mentioned last time is the range of values that input variables and output variable can assume. The quality variable can have a range of values 0 to 10. So we create from numpy a range function a range of values. For service, again 0 to 10, and tip amount 0 to 25. Let's say dollars. Then let's generate membership functions now. So these values we agree that are not sufficient enough to express fully and capture fully the uncertainty in the information residing in the rules. Rules are talking about high amount, low amount, medium amount, but we don't know what amount is high. Same amount can be high and medium at the same time, right? So in this particular case, we are going to use a specific most common membership function, which has a triangular shape. In scikit fuzzy package, this function can be generated using this function trinmf, which is triangular membership function. We will fuzzify these variables, food quality, in three fuzzy sets: low, medium, high; service in three fuzzy sets: low, medium, high; tip amount: low, medium, high. In practice, you will be dealing with more rules, more subsets, fuzzy sets, and more levels. But to understand how to use the library, this much is enough. Now, the formula that this triangular membership function is using to create the fuzzy membership of the elements and universe of discourse is very simple. Take a moment and look at this function. This function will be applied to a value of x. X can be quality of food, service, or output, and it will apply these three constraints, numbers a, b, c. If x is less than equal to a, the membership will be 0. If x is between a and b, the membership value will be calculated by this fraction x minus a over b minus a. If x is between b and c, the membership value will be calculated using c minus x divided by c minus b. If x is greater than c, the membership will be 0. If you notice, the membership for any value of x increases in the segment A to B, and it decreases from B to C. Let's see how we generate. If you remember, we created three ranges from NP A range function for X quality, X service, and X tip. Now we are going to say that these three ranges are going to X quality range, let's say, is going to be fed into triangular membership function like this. Triangular membership function with A, B, C values 0, 0, 5. A, B, C are 0, 0, 5 for X quality membership function, and when X quality is low. So for this particular triangular function, we will subdivide members of X quality 0 to 10 using A, B, C values 0, 0, 5. And for medium quality, we will use A, B, C values as 0, 5, 10. And for high quality food, we will use A, B, C values as 5, 10, 10. Now, we'll do the same with service quality and tip. So both the input and output variables are now they have now become linguistic variables. Quality low, quality medium, quality high, service low, service medium, service high, tip low, tip medium, tip high. Let's have a look on the food quality membership function for low, medium, and high fuzzy sets. We'll print the values of X quality low, X quality original values, quality low, quality medium, and quality high. You can see for quality low, the function is maximum at 0. When X quality is 0, quality low is associating 0 value with the membership 1. 1 value is in the quality low, the membership value is 0.8. 0.2, no, 2 is 0.6, and so on. It's decreasing. After 5, quality, if the food quality is more than 5, we cannot say the food quality is low. That's why the membership to this subset is 0. Any questions so far?
Yes, sir. I have a question in like how did we do like quality low first or trim F? The ABC value is 005. Like how do we choose that one?
You look at the universe of discourse, which is 0 to 10,
Mhm.
and you look at your fuzzy set quality low. Fuzzy set cannot be, you cannot say quality is low if this quality is more than 5, right?
Mhm.
And you cannot say quality is low when it is 4. It is slightly low, but it is
Mhm.
not as much low as 0. So you need a function which is maximum at 0 and minimum at 5. It decreases from 0 to 5.
Mhm.
So ABC005, if we put here X less than equal to A is 0. And this condition is not going to be true for any of the values for quality low because your minimum value is 0, right? Between A and B, your membership value is going to be X minus A over B minus A, right? And that is between A and B, you have nothing to calculate. B is also 0. So this is gone. Then B to C, your membership values will decrease when you say C minus X divided by C minus B. So B is 0, C is 5. So every value will be divided by 5, and C minus X, 5 minus 4 divided by 5 will be 1 by 5,
1, 2.
right? 0.2. So that 0.2 is here. And for next value 0.4, 0.6, 0.8, 0.1. So you will imagine how your function should look like. You can use a pen and paper. On x-axis, you put the range of values that you call universe of discourse for quality 0 to 10. So for when quality is low, how the function should look like. So you draw that function, and based on that drawing, you can decide values for A, B, and C. Simran?
First, I didn't get like how do we choose the value of A, B, and C for all these three? Like
Hmm.
you did 0, 0, 5 and then 0, 5, 10 and 5, 10, 10. Like
Hmm. So let's assume that we have this drawing before we created the variables. We decided ABC. We have this drawing, okay, for our fuzzy set subsets. On x-axis, we have the universe of discourse, 0 to 10 values. Let's first discuss food quality as low. We want to decide ABC for X quality low. So for that, the low membership will be highest for service. Oh, sorry. Yes, food quality. When food quality is 0, you will say that this value for 0 value is the membership to low quality or bad quality food is highest. That makes sense, right? And as the food quality increases, the membership to the bad quality food decreases, right?
mhm.
So we with pen and paper, we draw this. So from this drawing, can you decide ABC? From the blue line? And looking at this, first we decide the shape of the function will be triangular, okay? And where shall be your C value? Looking at these rules, you want to say that beyond that point C, the membership will be 0. So you decide where you want to put your uh, the C value so that when service quality is more than C, the membership to bad fuzzy set will be 0. You can decide it to be 4. You can decide it to be 2 or 6. So C, you will, when the triangular function ends, the, the membership value becomes 0, you will put C there. Okay. And where do you want to put B? The point from where you want to decrease the membership value up to C. So this from B to C, 0 to 5, the membership value will decrease because of this third uh, condition here. Simran?
Right.
And in this particular case, below 0, we don't have anything. So A and B will both be 0. But now let's look at decent quality. Decent quality will be represented, let's say, again, using a triangular function. So decent quality, can you say the service quality is 10? Can you still say it's a decent food, or you will say it's a great food?
Then it's gonna be great.
10 should be great, right? That's why you will put C at 10. Now B will be where? The point where you want to reduce the service quality up, no, food quality, the membership to decent group will reduce. So B, if we make B at 5 for decent group, decent fuzzy set, then at 0.5, the membership to decent fuzzy set will be maximum 1. Which makes sense. If food quality is 5, we can say that it's a decent food with full membership. We say it's a decent food. Below 5, it's not, it's decent, but not as like fully decent, right? Below 5, the membership to decent should start decreasing. So where do you want to, maybe from 2, if we say from 2, we want to increase the membership to decent food, then we will say 2 is our A, up to 5, and up to 10, C is 10. Now let's say we want to change it. So the decent group should give 0 value from 0 to 2. And it should give 0 value from 8 to 10. In that case, what will be the values we will be using for A, B, C? I will repeat, 0 to 2, not decent. Membership should be 0. 8 to 10, not decent. It must be something other than decent, not just decent. And between let's say 2 and 8 at 0.4, perfectly decent. So for these 3 scenarios, given these 3 scenarios, what will be our A, B, and C? Mikhail? Roshandeep?
Yes, sir. So if
So
you can just scroll down to the membership function once.
food quality, we are deciding that the decent fuzzy set should be changed. We are saying that 0 to 2 is not decent, and 8 to 10 is also not decent. 4 is perfectly decent. So we are changing the shape now. So what A, B, C shall I use? Jasmika proposed 0 for 10. Simran proposed 0 for 10. Rithang proposed 2 for 8. So if you have other opinion, you can give in the message, or if you have same opinion, just like whichever opinion you like in these 3 options. Roshandeep said 2 for 10. Biraj? Mikhail? Jasmika changed her opinion, 0, 10, 4. Anish? We are 32 members, only 4 messages won't work. If you are not following, I will be very happy to repeat this scenario. We are trying to understand how to design a fuzzy membership function. We look at the universe of discourse. We are dealing with food quality variable. Food quality can be 0 to 10. But now we want to make this variable a fuzzy linguistic variable. And in that, we need to decide a set. 0 to 2, we don't want to consider as decent. 8 to 10, we don't want to consider as decent. 8 to 10 should be great or something else, but not just decent. 0 to 2 should be something else, but not decent. And around 4, we say perfectly decent food would be with food quality 4. Purnima, thank you. But only if you're giving same opinion instead of writing a new message, you can just thumbs up to the opinion of Simran or Rohitang or Roshandeep or Jasmika. Jasmika changed her mind. The question is, where shall be the inflection points? Using values for A, B, and C, we are trying to make a triangle. Triangle. Below A, triangle will give 0 membership value. Beyond C, it will give 0 membership value. Do we have whiteboard? Around 10 replies. It doesn't help me really to move on, but we don't have much time. So let's try each answer. All right. Jasmika 0, A 0. All right. Jasmika, which line are we going to change to create the function now for decent quality food?
It should be the medium quality MD.
Quality
Oh,
MD, line
sure.
number
Sorry,
4,
which
right?
should be changed to like 0 to 2 should be already 0.
All
And I'm
right.
thinking the middle should be, because middle is still perfectly decent, should be 4, should be the number 10 should be replaced by 4 because that's perfectly decent. That's why I put 0. I changed it to 0, 4, 10.
Right. So if we look at these rules beyond C, we want our value to be 0. So C should be 8. Beyond 8, we don't think the food is just decent. It should be something else. And the below 2, we don't want to consider food as decent. It is something else but decent. And perfectly decent will be B, which is we are changing our mind. Instead of 5, we are saying 4 will be decent food, perfectly decent food. 4 to 8, the membership to decency of food will decrease. 2 to 4, A to B, and if you look at the second condition, A to B, it will increase. It will maximize at 4 and then start decreasing up to 8. If I run this, let's look at the individual values. For medium, you see it's below 2, it's 0. Up to 4, it is increasing, and up to 8, it is decreasing, and beyond 8, it's 0. When we plot it again, the plot should reflect what we just designed. So now the membership is the green triangle for decent food. The definition of fuzzy set is changed now like this. Below 2, the membership is 0. Beyond 2, the membership is 0. Beyond 8. Between 2 and 8, membership increases up to 4 and then decreases, start decreasing up to 8. Does it make sense, Simran?
Yes.
Now ABC makes sense?
Yeah. Thank you.
Jasmika?
Yes, sir, it does. It's just that I got confused when you said 8 to 10 not decent. I would have expected it to be 8 to 10 is perfect, like great. And so I was like, okay, how am I going to place both of them in that equation?
For perfect, we have another function. Now the red line, red triangle, is representing great food. Now let's change the definition for great food. We will consider great food only after 8. Or let's say after 6, food is start to become great, not fully great, but closer to great. And at 10, the membership to great is perfect, 1. So if I want to say not 5, but from below 6, food cannot be great. Below 6, food cannot be great. And then based on this one statement, what will be A, B, and C? So Yali, whoever didn't reply to the first question, please reply to this one. Below, we want to define membership function for great food quality. And for now, it is saying that the red line is representing great food membership function. And it is saying that below 5, food cannot be great. And above 5, food is getting increasingly becoming great. So if we want to change that, 6, 10, 10, Simranjit, thank you. Let's try 6, 10, 10. So food quality high variable, we will change below A, the membership should be 0 to great. So we say A is 6. From 6A to B, it should increase continuously, increase. Every next number should increase the membership. So the next number is, let's say 10, up to 10. And C will be 10. B to C, the membership remains the same. All right, 6, 10, 10. When we run this, and look at the membership for quality, you will see up to 6 it's 0. After 6 it starts to increase, and for 10 it is 1. When we run this, now the shape is changed, right? So Simran, thank you so much. You asked a very pertinent and important question, how to design membership function. My suggestion is we take pen and paper, draw a line that captures the range of X or universe of discourse. Here we are dealing with food quality, service quality, and tip amount. In real projects, your range will be different. Tip amount range is 0 to 25. You can change the shape of tips as well for fuzzy sets. For every the linguistic variables that we are defining here with respect to membership functions, we are just having 3 membership functions for every linguistic variable. You can put more depending on the context and situation you are dealing with. You will be deciding the shape of the membership function and how many membership functions you will need to capture the uncertainty in that situation, to allow one member of the group belong to more than one sets. Tejas, very nice, very nice. We can. So Tejas, this is kind of counter theory, right? So again, we are facing with the same problem that we started with. 5.5 will be 0. So it's again fuzzy set will be facing the same problem that crisp set faces. So for that, you can have a different shape of function. Right now we are using only triangular functions. You can use sigmoidal functions. Sigmoidal is S-like function. It can start from 0, slowly start from 0, going up, 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 and then become 1. Tejas?
Yes, sir. Makes sense to me.
Right.
I was saying it from a lower bound perspective, but your sigmoidal idea makes a lot of sense as well.
So
Because once we start thinking about floating numbers, that's how it has to go.
right. So for the sake of simplicity, we are restricting ourselves only to triangular functions. But in real life, you will be having more than one options for membership functions. Even in this library, if you go to the documentation here, sorry, this is not the documentation. This is the actual example that we are working on. Documentation link is here, up to here, scikit fuzzy. If you go to URL, you will see the membership functions. You have more than a dozen different options: sigmoidal, trapezoidal, triangular, and convex, non-convex. So just taking pen and paper and drawing what kind of function will capture better your situation, and then using corresponding shape from the API is what you will be doing. Now, next question. Value 3, service quality 3. How would you interpret that value? So you get a crisp value 3, you want to fuzzify it. It will belong to how many sets? To set fuzzy set great, the membership is 0. To fuzzy set decent, membership is 0.4. To fuzzy set bad, membership is
0.4.
Thank you, Nikhil. So we will look at y-axis on the point that we want to calculate the membership value, fuzzy membership value, and we now have food quality 3 belonging to 3 different groups. We are allowing 3 different sets to contain 3 with different degree of membership. So fuzzifying this with manually is not the option now. You need a function that can calculate membership value, right? So after we have defined all the membership functions for every linguistic variable, now we pay attention to how we are going to program the expert system. So to make these triangles useful, we define fuzzy relationship between input and output variables using these 3 rules. Let's solve some questions to understand how the engine will work. What would the tip be in the following circumstances? Food quality, the customer says 6.5. Service 9.8. So we will feed this information to our linguistic variables, and outcome will be the membership values. There's a function interpolate membership. All right, in the fuzzy package, it will give us what? The degree of membership on y-axis we call mu. For a given value of x, the corresponding y value will be given for the variable that you input. So first argument will be your triangular function set, and the quality low will be the array that gives the values for membership function, and the crisp value 6.5. 6.5 belongs to quality low. How much? This interpret membership will return that value. If we run this, 6.5 belongs to low quality fuzzy set 0.0 membership value. 6.5 belongs to medium quality food quality fuzzy set with the degree of membership 0.375. 6.5 belongs to great quality food with membership value 0.125. Where is 6.5? Here, 6.5 belonging to great is 1.25. Belonging to bad quality is 0. And belonging to decent quality is around 0.4, 0.3 point something. So we get that 0.375 to medium, 0.125 to high, 0 to low quality food. Anything outstanding or confusing or fuzzy here? Sagunash?
Uzair?
Nikhil?
Yeah. So in that the first line, you have provided X quality low and 6.5. So why we are giving the X quality function? X quality array.
That is the x-axis. Values on x-axis will be the first parameter.
Yes.
Values on y-axis will be the second parameter. Now,
Okay.
the second parameter will be the membership function, the membership values. So just a minute. This is first parameter, this array. The second array is the second parameter. Okay.
Yes.
And third parameter is your crisp value, whatever the customer says. The food quality is 5.5. So it will interpolate. The function did not define values between 5 and 6. We just defined these points 0 to 10, 0, 1, 2, 3, discrete points. Quality low array is giving discrete values for each point in X quality, but membership function, interpolate membership function will be doing this interpolation. So between the points, 6.5 is not in this set, in this array and in this array, but it will interpolate and return you the corresponding value. Okay. Nikhil?
Yeah. Yes. Good.
So first parameter is going to be what? X-axis. Second parameter is going to be your triangular or whatever shaped membership function values. And third parameter is your input from the environment. You will get a crisp input, and membership function will interpolate using these two arrays the corresponding membership value for your third parameter. So for high, low, and medium food quality, you get three numbers. These are what? These are the membership, degree of membership values for 6.5. Membership to each fuzzy set, low, medium, and high food quality. Same you will do with service level. And for service level, 9.8. If service level is 7, what do you expect the membership value for service level 7? Jasmika, service level 7, service quality 7 will belong to poor fuzzy subset. How much?
0.
And Riddhi, to the amazing fuzzy set, 7 will be how much in the fuzzy, in the amazing subset? Riddhi, you can type if you don't have mic. Riddhi Thakur. Anyone else?
More than 50%. I mean, 0.5, more than 0.5.
Less than 0.5, around. So 7, if it will go to nearly 0.5, nearly
Yeah.
0.4, nearly 0.4. Let's see how membership function. And for being acceptable service quality, acceptable service quality is captured by this green rectangular function, triangular function, and the membership will be
0.6.
for 7 will be 0.6 around. So let's run that and see for 0.7. And so for 7 value, the service quality for the medium, it's 0.6. You are exactly right. And for high, it's 0.4. I was right. So my drawing skills are better for this membership function, high. And your drawing skills are better for medium. We are even, Nikhil. Together we can make a good fuzzy expert system. So we just defined two variables. How about the third one? Third one is tip amount. Tip amount will be used when? The stage one, we take the input from environment. It says how much fuzzy, how much is the service quality, how much is the food quality. We get two numbers. We fuzzify them using interp membership function. Interp membership function is fuzzifying two crisp numbers into 6 fuzzy numbers, 3 for food quality and 3 for Sanket. Sanket Patel. Sonal. Zero 4110. I didn't get it really. So two input values will go into the system, and fuzzification component will generate 6 values. 3 for the food quality and 3 for the service quality. Okay, Sonal? Jason? Let's stop here and try to digest. Till now, we are doing fuzzification of a crisp input. This system is taking two crisp inputs, two numbers, one for food quality, one for service quality. Fuzzification component of expert system will take these two numbers and give us 6 numbers. 3 numbers for food quality and 3 numbers for service quality. We will use these 6 numbers in the fuzzy inference engine to evaluate these rules. How shall we evaluate these rules is very important now part. Now we are going to use fuzzy operators. So quality level low and service level low. These are the rule number 1. Rule number 1 is food quality is bad, which is represented by quality level low, or the service is poor. Poor service is represented by which triangular function? Service level low. Now, or is in fuzzy logic, Boolean or is represented by fuzzy max operator. So you will do fuzzy max, F max operation on quality level low and service level low. It will give you, it will activate rule number 1 and give you the output of activation of rule number 1. Rule number 2, we will provide, do rule number 2. Rule number 2 is what? If the service quality is acceptable, then the tip will be medium. If the service quality is acceptable, we can say acceptable means medium level service, then the tip will be medium. So we will this if else, if then will be represented by Boolean and fmin function. If this, then this. If service quality level medium, then tip is medium. So we are taking fmin for both for implementing this rule. So tip activation will be medium. If we print tip activation medium, we will look at these, we will get these numbers, and instead of looking at these numbers, it's better to print them, their shape. It will make more sense. We will look at the shape in a moment. For rule number 3, we are saying that if the service quality is high or service level is high, food quality is high or service level is high, then in order to do this or, we will do f max. In the Boolean or is represented by f max. The corresponding operator for Boolean or in fuzzy logic is f max. Corresponding for Boolean and fuzzy logic operator is f min. So we do f max here, we get activation values for rule number 3. If we print that, we see the activation value 0.96. And we say that if the rule says that either of these, if the food is good, high quality, or service is high quality, then we pay high amount of tip. This if and then will be implemented using f min. So we'll do f min on 2 sets, activation rule number 3 and tip high. Tip high is represented by this red triangle. Tip medium is represented by this green triangle. Tip low is represented by this blue triangular function. So we did what now? We applied the rules. If part, we combined the conditions using the triangular functions and we get an output. Activation of rule number 1. If part, we implemented if part is on line number 3. And then we part we did f min on activation of rule number 1 and tip low. Tip low is this blue triangle. OK. Any confusion? We are doing evaluation of the rules now after getting the fuzzifying the crisp inputs. We got 6 numbers. Now we are using those 6 numbers to evaluate and activate the rules that we have in the system. Rule number 1. Rule number 1 needs. It works on triangular function quality level low and triangular function service level low. The value for quality level low and service level low is here. Quality level low and service level low. We calculated using interpolation of membership function. Other than linear interpolation, Rohitang, it depends on the type of the membership function. For triangular membership functions, linear interpolation is working perfectly well. But if you have sigmoidal or nonlinear membership functions, then you can use nonlinear interpolation for the corresponding function. Very good question. Let's let's take your inputs at this point. Your understanding at the scale of 0 to 3, 3 to 6, just 6 to 9, 9 to 10. Thumbs up. The speed of your answers This is a fuzzy question. I need 33 answers. We are 33. So I got just 13 answers. And the fuzzy system is working very slow. In fuzzy inference engine is very slow. Simran. I think I should make this poll private, right? Everybody can see, and that causes a little bit of shyness. But Imran, are you there? Can you talk?
Hello.
Hi. So can we go through this example again together?
Yeah, we can.
All right. So
Very
we have.
confusing. I mean, a lot of things. There's no. I'm not able to make a connection between all these.
That's why let's go walk through together. We have how many inputs?
Inputs, food quality, and first graph you are talking about?
Yeah, we have two inputs, food quality and service quality.
Okay.
We have one output, tip amount.
Hmm.
So fuzzy inference engine will take two numbers, one for food quality and one for service quality. It will fuzzify those numbers. First, it will apply these membership functions to food quality number. So from food quality 6.5, we will get three numbers.
Now, food quality, we have three. Can you go up?
Food quality, we defined
So,
it can be of three.
yeah, the thing is like there are three bad, decent, and great food. So,
Right.
what is the relation? I mean, between these all three, where they're crossing these lines? So, I'm not sure. These are independent. Looks like these are independent, but these are cutting each other. So, making some sense. I have no idea.
That's the point of this linguistic variable. Food
Yeah,
quality.
so either we should, I mean, very understand in descriptive way, like food quality is bad or good or great, then we say, okay, service quality good, bad. But we
Right.
are at the same time calculating numbers also, so that is making confusion.
Right. So when we fuzzify, we map one number to multiple membership functions. So one number can be a little bit of great and little bit of decent.
Yeah, that
A food can be decent and great at the same time
yes.
with different degree of membership. So we define degree of membership
But these
using
degrees
these.
of membership are independent. I mean,
They are separate sets.
yeah,
So
those are independent. So why are we putting it all together here?
we can use three separate graphs just to discuss food quality in one graph. I put all three membership functions on one graph, but
Okay,
we
then.
can have three different graphs.
Okay, so I'll go through it. No problem. I think that resolves the problem.
So when we say food quality 3, let's say 3, and 3 will go to three membership functions. Quality low, quality MD medium, quality high, and then we
So
interpolate.
when we say three, we are trying to find out three is good, bad, or is just decent.
Right. So it will be the membership with the bad will be 0.4.
Yeah, so we are trying to get like how bad and how good and how decent.
Right.
That is output.
Right. So same thing we do with service quality.
Yeah.
This process we are going to call fuzzification. Fuzzification is the first step in inference engine. Next, we are going to evaluate the rules. Rule number 1 is that if food quality is bad or the service is poor, then tip will be low. Now the if part has or in it. Or.
Yeah, so when it is or, you are saying maximum. When it says and,
F
you're saying
max.
minimum. So what is the reason? I mean, why we are doing this? We are interpreting something from the graph, or it's just a rule? I mean, why does it? Why this rule is?
So in case of Boolean, if you say or, it means between 0 and 1, or will be 1. The output will be 1, right?
First, whatever comes first, that is accepted in like
Right.
Boolean.
0 and 1, if we do or on 0 and 1, then output will be 1. But in case of fuzzy, we don't have 0 and 1, we have values between 0 and 1.
Yeah.
So quality level low and the service level low, if we take or of them, the maximum will be the output in case of fuzzy. In
So
case
this
of
is
Boolean.
we are defining. I mean, that is a business problem, right? We can say no. This is not to like. We say okay, we will take minimum.
No. In case of 0 and 1, when we take OR, what did you take? Maximum or minimum?
Like in
What is maximum between 0 and 1?
maximum is 1. Yeah.
1, right? So correspondingly, in case of fuzzy OR, we will take maximum value. Since we don't have either 0 or 1, we have values between 0 and 1. So between two values, if we want to take OR, we will take maximum value. That makes logical
So
sense.
that's a rule, mathematical rule for fuzzy.
Right. This is fuzzy OR is maximum, F max, which corresponds to Boolean OR. Similarly, Boolean min will be and. If you take and between 0 and 1, the output will be 0. See, corresponding fuzzy operation is a minimum. Take minimum value between two values. If you are doing and, take minimum value. That makes sense, right? And then if then part will always be implemented using f min function. So fuzzy min, whatever you have in the if part, it will be a set of values, and another set of values in the then part, if then. So you will take f min to implement if then rule.
Yeah, for or min and and
Right.
min max.
So first rule when we activate by using fmax, so active rule number 1, the value is 0 for activation of rule number 1, and we take min with tip low. Now tip low is what? Tip low is this function.
Out. Final out.
No, this blue function.
Yeah, last one. Okay.
Tip low. So we make from these two inputs, we make a third vector, and that take minimum with the corresponding rule. If part comes from the inputs and then part comes from the output triangular function. Okay.
So from the values of this first two graph, we are drawing the third one.
Right. First two graphs will give us fuzzy values, and using those values, we'll implement if then rule. So if part is coming from inputs, then part is coming from output.
Okay.
So rule number 1 we implement here, rule number 2 we implement here, and rule number 3 we do the same. In rule number 3 you see we are doing F max between these two, quality level high, service level high, two different triangular functions. We take F max because we have OR there, and then this activation of rule number 3, we do f min. This is the if part. The then part will be tip high from the rule.
Okay.
Tip high. And now you will be convinced when I draw these things. Let's run this immediately. And when we draw these outputs, you will really like it. Look at this plot. On the x-axis, we have tip amount. The blue thing is representing rule number output membership for each rule. Rule number 1, rule number 2 is green, rule number 3 is blue, red.
Okay.
So we take inputs, fuzzify, and apply the rules, and if part comes from inputs, then part comes from tip amount membership functions. And the outputs of those, when we plot, they look like this.
Okay.
So now, up to this point, this is still So we changed a little bit here. Let me, was it 005? 050, just to come back to the implementation we did, and 5, 10, 10, 5, 10, 10. And we had this.
It was 0510.
Oh, sorry. 0, 5, 10. C was 10. And now when we look at their shapes, they look like this. I intentionally make it like this. So we have input 6.5. 6.5 for food quality. The customer says food quality is 6.5. And the 9.8 is service quality. Now, just imagine in your mind, if you have this food quality and this service quality, using these three rules, how much tip you will be giving between 0 to 5? Will it be less than 10?
6.5, 65% of 5, right?
Tip.
Something, or you just take it to 6.5 around. More than 50% should be.
So let me take a survey. We can agree on something.
Tip values.
So please thumbs up to any tip amount, the range. Let's talk about range. If the food quality is 6.5, the service level is 9.8. Remember these three rules, and in your mind, calculate the range of tip that you will give to the to me if I serve you 9.8. And the food quality is so-so, but applying these three rules, how much tip would you be willing to give me? Heba, just choose in this range and follow the. If the service is acceptable, do you think 9.8 is acceptable service? Out of 33, just 5 answers. Are you guys with me, really? So service quality is very good. 9.8 is almost perfect, right? Service quality 9.8. Food quality 6.5. Following these rules, how much would you be willing to give me as tip? Mostly people are saying between 15 to 20. Let's see how much fuzzy system, after evaluating these functions, is doing. So evaluating these functions, rule evaluation, number 1 give us this, number 2 give us this, number 3 gives us this. Now we combine these 3 rules, we combine the output of if then rule number 1, rule number 2, rule number 3, when we combine and we plot, they look like this. The combined area for tip amount low, medium, high is like this. What is the center of this shape? If you think about the center, where would it be? Around 20, 25, 15, 5, where would it be the center? So Hiba, do you think 12.5? The center should be a point where you can balance this shape. Jasmika, 13, this shape will tilt towards right. The bulk of shape is to the right of 13. Food being average. Okay, food being average, food being average, food being average, food being rules don't say if the food is average. You're right. This is amazing question. Even if the rules don't say anything about average food, we can still calculate based on this incomplete information. That is the key question. Hiba Imtiaz, 20. Yes, around 20 is the center of this shape. Around 20 will be the amount that most of you agreed to pay to me for serving you the best pizza in town. So when we this part is called composition. We compose the outputs of low with the output of medium and high. Tip activation high, tip activation medium, tip activation low. We take max of all. So since we work in pairs, we do max of medium and high. The output we take max with activation low, and that is our aggregation. Aggregation is this filled area. For tip activation low, the filled area is around here. It is hidden, all 0. Tip activation medium is this green. Tip activation high is this red part. We aggregate all of them and we get this vector, aggregated vector. We have this area. Now we want to find the center of it. There are different couple of methods to find the center of this area. The best one, the most common one is centroid method. We find the center of this shape using defuzz method. Defuzz method will take your variable that defines the tip amount, x tip, and the aggregated vector that you just got here, and you will say that I want to use centroid method to calculate the defuzzified amount of tip, and it is 19.86. So even though Hiba, we don't do in the rules, we do not define the tip for medium or average quality of food, but even that information is missing from the rest of the rules. The fuzzy inference system is able to compute something very much sensible. 19.8. So step 1, fuzzification. Step 2, rule inference. Step 3, defuzzification. Input will be crisp, output will be crisp, but inside the system is working with linguistic variables using fuzzy operators. Imran, isn't it amazing?
Yes, it's amazing. I'll have to practice 2-3 times.
So when you want to plot how much the amount you will get, this is the point. This is the center point for this shape, and you will pay this amount. Okay, and this amount has 0.57 on the y-axis. We put tip activation rule. Tip activation, when we interpolate, it is 0.57. So 19.58 will be the amount you will pay. Now change these values, and even though we are looking at a notebook, we need to run many cells. Put this code in Pi format, in Pi module, and change this tip amount and everything. For example, the food quality, change the food quality, change the service level, and look at the output. Does it make sense? And this is how you will be doing implementation of fuzzy inference systems. Biraj? Jasmika?
Yes, sir.
Are you liking it? Are you confused? Any questions?
I think I'm following. It's a little difficult, but I'm following.
The last part, aggregation, is applying fuzzy OR, F max on all the output membership functions. So for tip activation low, there will be some values in that. Tip activation medium, there will be some values in that. Tip activation high, all values, you will pairwise OR them and take the maximum. That is the aggregate of all three rules. If you have five triangular functions defining your output variable, you will take fuzzy OR on 5 variables, 2 by 2. And the end of the day, you will get the aggregated for fuzzy membership function high, how much this rule is activated. The area under that triangle will be given to you through the fuzzy engine. For the medium, how much? For the low, how much? And then you will combine all three using fmax functions, aggregated output, and find the center of that aggregated output. That is the defuzzified crisp output of your system. So you just mastered a wonderful technique for building expert systems using fuzzy logic. I hope you will enjoy making your project using fuzzy logic or simple rule-based systems. Remember that end of the semester you have to work on a project, which is part of your course. 20% will come from there. Next week you are going to have a midterm. So can you attend midterm on Tuesday evening, 2 p.m.? All right, then we will have midterm in this session next Wednesday. We will go through our normal class with the next topic, which is ANN. And after that, we will have midterm exam. So don't miss it. Missing a midterm exam will make you prove that you were unable due to some emergency, like letter from a doctor or something. You travel to Mars or something, proof of that. Okay, so don't miss any quiz or exam unless you have no other choice. All right, so if your doctor says that you cannot go to your couch and open your notebook and give me that certificate, and then only in that case you will be able to you can miss the midterm exam. Otherwise, don't miss. Okay, do not miss an exam no matter what. So next week everybody should be present. Okay, and by next week please register with the let's make a channel in the Teams for the project groups. I think I already made course project channel, and there is quite a lot of activity going on there.
Excuse me, sir.
Yes.
For the final project, it can does it has to be specifically fuzzy logic, or it can be the PyNow library that we learned in the last class?
Anything. Fuzzy logic is one option.
Okay.
So I see there are 12 and 11 projects. Yeah, 33. So you not 33 actually, 10 projects. So if you haven't joined a team or created a team, please go ahead and let me know by next before midterm. You create a separate sheet for your project here and provide me the details, like what do you think about your project? Where will you get your rules? How many rules will you contribute? Etc. Okay, you can create a separate sheet for here. All groups are in this sheet, and register yourself and start working so that you don't have to do things at the 11th hour. Okay.
Sir, another quick question about the project. Does it have to include some sort of a machine learning concept inside it, like NLP or something, or computer vision or something, or can it just be purely rule-based expert system?
It can be. It can. You can make an expert system based on data driven. So you make your rules from data coming from an object detection system or something, right? So it's up to you.
Okay, thank you, sir.
So Jasmika, next the midterm format is it will be an online exam asking you some conceptual questions, multiple choice, fill in the blanks, short answer about the content that we have covered till now.
So can we not have negative marks like last class? I think that's just so pulls you
all
down.
Right. All right.
Because it's very hard
So,
for you to, but we're trying to make sure we understand as opposed to by hearting something.
So making a wrong choice in multiple choice question is it's okay. If you want, I will. So how shall I All right, we can work on that. So we
So
will.
how about just asking questions on all the topics that you asked us to put in that spreadsheet?
Yeah, I will be
So many
using that
topics there.
spreadsheet. I will be using that spreadsheet to prepare the midterm exam. Contribute as many questions as you want to let me use your questions. Okay, so keep contributing, and we'll be good.
How about coding questions? There'll be coding questions also.
Coding questions. There'll be conceptual questions. Coding will be evaluated in the project.
Okay.
Sarah, I had a question in regards to the project. So say for we're considering doing a chess rule-based knowledge system, do we need to have like a GUI component where you can see the user playing like a two-player chess game or something, or is it strictly you just need the rules?
Rules are must, but if you put a GUI and make it look nice, it's it's like cream on the cake. So, but GUI is not really needed, not the must part.
Okay, right. Thank you.
All right, then let's call it a day. I will see you next week. Keep me posted on this channel. If you have any question about the topic, just tag my name and I will explain, and see you next week. Thank you everybody. Bye bye.